ole zanin tuna chuan India rama coaching thaber polangai Akash ho test question kan zirle don ni tuna kan ti tur hi kinetic theory thermodynamics le heat transfer ania question number 1 atang hen lo entran ta ila question number 1 chuan intensive property among the following is aritani mo enge intensive property intensive property kan ti chuan thermodynamic property gas property chi khatani ta amaro chu I amount of substance in khat lo ani amount of substance in khat velo substance entina number of moles ate khatiang a molecule tamle tamlo ate khana in khat velo ta ni amount of substance in ngat low ani ta ni chuan internal option e tang hen an en taila internal energy u chu number of moles into specific heat get constant volume into T khani ta ni internal energy number of moles in khatania chuwang chuan intensive property chun lo ta volume pon ni lo chianga heat capacity pon lo ta heat capacity po kha number of moles in khatani ta ni chuan answer chu option D hi ni molar heat capacity ngatinge heat capacity ai hi intensive ani silawa ngatinge molar heat capacity kan ani na chan kan ti chuanin molar heat capacity chu heat capacity for 1 mole ani for 1 mole ani 1 mole ani to kha in fix don sa 2 mole pon ro se molar heat capacity ni chon for 1 mole khan ni don rim ta ni tikhan answer to option D khan ta a next question number 2 na notile taila a spherical body of radius 10 cm radiates 300 watt at 227 degrees Celsius if the radius is doubled at and temperature remains same the power radiated will be tan hi chu black body radiation kharita a ten spherical body kha om ta se black body alo zoom ta la radiation a pe chhok ta ni ti hian chuan a radius kha 10 cm ani ta ni chuan a temperature kha 227 degrees Celsius ani ta chu Kelvin a kan le chuanin 273 plus 227 zange 7 8 9 10 ni ta 1 7 8 9 10 1 2 4 5 ani ta ni chuan if the radius is double ta ni mo a radius kan double ta ni 10 cm tang khanin 20 cm kan double ta ni radius ka chuan a temperature ro chu langai reng temperature kha 227 degrees Celsius alani reng ta a so chuan a power radiate kha engzang nge niang ari ta ni mo chuan a formula chu black body radiation formula kha sigma a t power 4 khani ta a chuan chu area a hi area ni surface area a hi surface area nia chuan surface area of a sphere chu 4 pi r square khani into t power 4 khani chuan a hian in 300 watt power a radiate ta ni sigma into 4 pi r square into t power 4 kha 300 watt ani ta ni chuan a radius kha kan double ta ni r kha 2r temperature chu langai reng ta a chuan new power chu tur chu sigma into 4 pi 2r square into t power 4 khani ta ni chuan p prime chu sigma into 4 pi into 4r square into t power 4 chuan 4 times more sigma into 4 pi r square t power 4 khani ta hei chu 300 watt khani ta ni chuan new power radiate chu 4 into 300 chu 1200 watt khani answer chu option B khani option B khani chuan dot le question number 3 akal le ta ila a liquid cools down from 60 degrees Celsius to 50 degrees Celsius in 5 minutes the time taken to cool it from 50 degrees Celsius to 40 degrees Celsius in same surroundings will be atitani le liquid om ta ati hian chuan atira chuan temperature kha 60 degrees Celsius ani tani 60 degrees Celsius kha atla niam chara 50 degrees Celsius atlang niam chung kha minute nga ni tani chuan 50 atang hianin 40 a tlaniam don ta sela minute nga ai na rei nge rei lo zo kang ti kha kan zon tu chuni ta ni le heb tiang problem hi chu Newton's law of cooling Newton's law of cooling kha kan manga ta chuanin 60 minus 50 more rate of cooling by time taken 5 minutes more k nei ta chuan hemita pani average kan la doni 60 plus 50 by 2 minus t heat surrounding temperature ni ta sela chuan hi chu 10 by 5 ani ta ni k ni ta a chuan 60 plus 50 chu 110 ani ta 110 by 2 chu 55 ani ta ni 55 minus 10 ni ta ni chuan hi equation 1 lo ni ta sela adot lia chuanin 50 to 40 ha kan en le tur nei ta ni 50 to 40 ha kan en le tur nei ta ni chuan temperature difference kan langa 50 to 40 by t ti ta se ke 50 plus 40 by 2 minus t khani surrounding temperature angai renga chuan hi po 10 ani ta ni 10 by t equal to k times 50 plus 40 to 90 ta 90 by 2 to 45 minus t khani chuan a answer tur chu hei hemi te pani kan khai khin don ani right hand side left hand side hi chu rate of cooling khani ta ni avo chak jong a boro a temperature tlak nim chak jong khani ta ni chuan right hand side hian chuan 55 minus t o my equation 1 a chuan equation 2 a hian 45 minus t om ta ni since 55 minus t is greater than 45 minus t. This implies 10 by 5 is greater than 10 by t khani. So chuan in ai tian in kat theta a 5 is 10 by 5 is greater than sorry ti hianin 1 by 5 is greater than 1 by t ni ta ni chuan tatang chuan in t is greater than 5 minute more chan chu ta hianin hei numerator in anga denominator a khan 5 le t om ta ni chuan helam pang hi atam zoka ni chuan denominator claim zok ti ani helam pang hi tam zok ti na so ti ni chuan in 60 degrees Celsius to 50 ka 5 minute ni zone 50 to 40 ka minute ngai na tam don ti na ni answer chu option B khani greater than 5 minutes khani number 3 answer chu option B khani greater than 5 minutes chuan number 4 kan tilang number 4 chuan in an isobaric process of an ideal gas the ratio of heat supplied to work done by the system is aitani isobaric aron titani isobaric a chuan enge constant pressure ani pressure is constant isobaric a chuan pressure constant tani chuni chuan constant pressure a khan heat supply ta ila a heat supply le work done ratio kha zan tur tani le work done demo sapotang work done chu p delta v khan ya isobaric a chuan mo pressure constant ta chuan p delta v ideal gas equation tang khan p delta v chuan in nr times delta t khat luk ta ni chuan first law of thermodynamics and heat can supply chu the change in internal energy plus work done ani ta change in internal energy plus work done chu n cv delta t khan ta ni delta e khamo plus w chu nr delta t khan ya chuan in khi common alak the n le delta t common ta n delta t cv plus r ani ta ni chuan chu cv plus r hi chu cp khan ya n cp delta t khan ta ni chuan ten han ti phot taila heat supply to work done mo ncp delta t by nr delta t khani chuan n le delta t in cancel thea chuan cp by rl chuang ta ni chuan cp kha cv plus r khani ta by r mo chuan q by w chu CV by R plus R by R ani ta ni chuan CV by R plus 1 ani ta a chuan CV kha F by 2R ani F hi degrees of freedom kha ani ta ni F hi degrees of freedom kha chuan in kha tain substitute tai la Q by W kha CV kha F by 2R ani ta by R ani ta ni plus 1 tro chuan chu 1 plus F by 2 ani option kan en chon gamma specific heat ratio te pani kha aron ta a chu ti ni chuan in gamma kha 1 plus 2 by F ani chuan chu ti ni chuan in 2 by F chuan in gamma minus 1 atluk dona chuan chu ti chuan F by 2 in atluk tur chu 1 by gamma minus 1 kha heta hin kan substitute anga Q by W chu 1 plus F by 2 chu 1 by gamma minus 1 LCM kan langa gamma minus 1 chu gamma minus 1 plus 1 ai ta a chuan Q by W tur chu gamma by gamma minus 1 option D khani number 4 answer chu option D khani next number 5 tila ila question number 5 kan tilang if the pressure of an ideal gas is increased to 8 times isothermally then its RMS speed will become x times the value of x will be aditani le RMS formula khalo enta ila root over 3 RT by m molar mass aditani chuan isothermally aditani pressure kha 8 times p a chodon ta a chuan isothermal a chuan enge constant isothermal a chuan temperature constant ani chuan han en taila ta hian RMS speed formula hian pressure om ve mi lo ta ni chuan ideal into temperature constant chuan RMS speed a constant doni T a constant chuan in T constant chuan in V RMS kha constant turani maro chu pressure ron ti se te kan tiang kan ti chuan ideal gas equation ka PV is equal to 1 mole la taila tro RT ni ta ni chuan heta RT a hianin PV kha data ula 3 PV by M ani ta ni chuan isothermal a chuan boys law kha en taila PV kha constant ani PV kha constant chu di chuan temperature constant chuan RMS speed kha constant dong thrim chu wang chuan in x kha 1 turani adang lam don lo answer chu option A khani option A khani chuan number 6 the amount of heat supplied to a system is 50 joule and the work done on the system is 30 joule then the change in internal energy of the system is aitani change in internal energy miron so tani tahianin first law of thermodynamics kan manga heat supplied is equal to change in internal energy plus work done khani tani le tahianin work done on the system atitani physics a chuan work done on the system hi negative akan la chemistry chuan positive akan la thungta chuan W hi minus 30 akan joule akan langa heat kha 50 joule ani tani chuan delta U chu Q minus W khani don ta 50 minus 30 chu 50 plus 30 delta U chu 80 joule khani answer chu option C khani number 6 answer chu option C khani ya next number 7 a monoatomic gas is at temperature 27 degrees Celsius the change in temperature of the gas when it is compressed adiabatically to 8 by 27 of its initial volume will be tani monoatomic gas omta a monoatomic gas tan chon gamma value kha 1 plus 2 by F ani tani chuan monoatomic tan chon degrees of freedom F hi 3 ani ta a gamma tu chu 1 plus 2 by 3 chu 5 by 3 khani chuan initial temperature kha 27 degrees Celsius ani Kelvin chuan 300 Kelvin ani tani chuan adiabatic process final volume tur kha 8 by 27 of its initial volume ani ta ni chuan adiabatic process ani ang khanin temperature le volume equation kha T v power gamma minus 1 equal to constant ani chuti ni chuanin T1 v1 to the power gamma minus 1 is equal to T2 v2 to the power gamma minus 1 ani ta ni chuan kan zon tura chu change in temperature ani T2 hi kan zong photanga chuan a difference kan la le don ni chuan T1 v1 power gamma minus 1 is equal to T2 ani v2 kha 8 by 27 times v1 to the power gamma minus 1 ni ta ni chuan T1 v1 to the power gamma minus 1 equal to T2 and 8 by 27 to the power gamma minus 1 ita v1 to the power gamma minus 1 chuan heile hein cancel theita chuan T1 is equal to T2 anita chuan 8 by 27 anita ni chuan gamma kha heta khanin 5 by 3 anita kha kan substitute 5 by 3 minus 1 anita T2 chuan 5 by 3 minus 1 chu 2 by 3 khani 8 by 27 to the power 2 by 3 khani tani chuan T1 le talemo T2 aita into 8 2 cube in kan ziak nga 2 cube to the power 2 by 3 by 27 to 3 cube anita to the power 2 by 3 ti hian kan teida 2 square to 4 anita chuan 3 square to 9 anita ni chuan T2 to 9 by 4 times T1 ita 9 by 4 into T1 kan sa kha 300 Kelvin anita ni 300 Kelvin 4 in 7 is 28 anita 2 4 5 is 20 chuan T2 khatu T2 kha 9 5 is 45 4 9 7 is 63 plus 4 67 675 Kelvin anita ni chuan T2 minus T1 kha zon tur anita 675 minus 300 chu 75 anita 6 minus 375 Kelvin 375 Kelvin change in temperature mo answer to option C khani option C khani 375 Kelvin chuan number 8 if P is pressure, V is volume, K is Boltzmann constant angor o number 7 hi thale lokang T2 kha 9 by 4 times T1 ita T2 minus T1 tur chu 9 by 4 T1 minus T1 khanita T1 ita 9 by 4 minus 1 chu T1 into 5 by 4 anita ne chuanin 300 into 5 by 4 4 7s are 28 2 4 5s are 20 75 into 5 5 5s are 25 2 5 7 37 adike 375 ani chuan number 8 kha en le ta ila if P is pressure, V is volume, K is Boltzmann constant and T is absolute temperature of gas, then the quantity PV by KT ritani PV by KT K hi Boltzmann constant ani hi hian enge NT atitani le ideal gas equation kha enta ila PV is equal to number of moles into R into T kha nitani chuan ta hianin PV by KT ron zot lat chuwang chuan in number of moles hian en lo taila PV by RT ritani chuan PV by R chu Boltzmann constant into Avogadro's number khani chuan in number of moles into Avogadro's number chu PV by K T khani chuan left hand side yan entaila number of moles into Avogadro's number chu number of molecules ani number of molecules PV by K T chu number of molecules ani number of molecules chuan answer chu number of molecules of the gas mo option C khani number 8 answer chu option C khani number of molecules of the gas chuan number 9 if Q, delta U and W denote heat added, change in internal energy and work done in the cyclic process mo cyclic process chuan in system kha cyclic process chuan in system returns to its initial state system kha entina tian akal kole cyclic ani zonin akal kolanga mo heta tang hen bultan ta sela akal kolanga a bultan a bokhana ron lele tani kha cyclic process ani ta cyclic process a chuanin change in internal energy zero ni achan chueng wange system kha initial state a lele wang khan total change ka chu zero ni ton ta ni le first law of thermodynamics khalo en le ta ila Q is equal to delta U plus W khan ta ni delta U hi zero ni wang khan in Q kha W ni don ta ni chumem je chu heat jong kha work dana kalvek don ti na ni ta ni option A dika B lawa C po ni answer chu D khani both A and C khani number 9 answer chu option D khani next number 10 if for an ideal gas value of R by CV is equal to 0.4 itani ideal gas kan ya R by CV kha 0.4 ita then the gas consists the molecules which are itani mo gas molecule nge ti khamiron zotani monatomic nge diatomic nge polyatomic ti khamiron zotani let chumi kan thia thena dan tur chu degrees of freedom hi kan zong don ni degrees of freedom tang khan gas nge ti kan thei don tani le CV formula kha degrees of freedom by 2 into R khan ta chu substitute taila R by nta F by 2 R tani equal to 0.4 ta chuan thian phot taila chuan hi chu 2 by F anita 0.4 chuan F chu 2 by 0.4 ita 20 by 4 to equal to 5 chuan F hian degrees of freedom hian 5 atlukot chuan gas chu diatomic ani tikhan answer chu option B khani option B diatomic kha answer chu ni ta ni chuan next number 11 the rate of energy radiated from a black body at 227 degrees Celsius is 20 watt. If temperature of black body is changed to 727 degrees Celsius, then its rate of energy radiated will be at itane. Le formula khalo en le taila sigma A P is equal to sigma A T power 4 khan itane. Chuan kha atira chuan 20 watt anita 20 watt mo. Chuan a temperature kha 227 atang khan 727 akan thak tani. Then chuan a rate of energy radiated mo power radiate kha exam nge yang itani P prime to chu sigma A T prime power 4 itani hi exam nge ti khan zon to chu itani leta han hi a black body kha a size kan thak silawa temperature cha kan thak wa chuan sigma A hi ang don tani P prime by P di taila sigma A chu en kan selanga T prime power 4 by T power 4 itani le T prime by T common power 4 mo chuan in P prime by 20 nita equal to T prime kha 727 nita ni mo ka Kelvin in kan letang plus 273 by 227 plus 273 to the power 4 khanita chuan P prime by 20 equal to 727 plus 273 to 1000 nita po 500 nita ni 4 2 to the power 4 nita chu 16 nita ni P prime chu 16 into 20 chu 320 watt ani answer chu option B khani Number 11 answer to option B 320 watt khane tani. Next, number 12. The internal energy of 1 mole of diatomic gas. Oh, internal energy for 1 mole of diatomic gas aditani. Le diatomic tan chuan degrees of freedom kha pangati khalo entaila chuan internal energy formula kha N into F by 2 R T khane tani. Chuan number of moles kha 1 ani tani. 1 mole mo degrees of freedom panga ta a F by 2 R ani ta a chuan in temperature kha 200 Kelvin ani tani. 2 in 100 chuan 500 R mo answer to option C khani. Option C 500 R. Chuan number 13. The diatomic gas undergoes a thermodynamic process. PV square is equal to constant mo. PV square is equal to constant anitani. Chuan the magnitude of ratio of work done by the gas to change in its internal energy. More work done by the gas to change in its internal energy. Let's change in internal energy khachu N into diatomic ani wangin F by 2R delta T. More diatomic to F khapanga ni ta degrees of freedom chuan delta U to number of moles into 5 by 2R delta T khane ta ne. Chuan hi kan nei mai ta a. Chuan work done khazong le don ta ila work done formula chu tianga work done chu integral of P dV khane ta ni. Chuan PV square is equal constant ta hen pressure hi constant lo tlat maya pressure hi a constant lo ta ni. Constant se chu pressure hi kan po chho the ta maro chu a constant lo awangin integral chhunga aw mangai ta ni. Integral chhunga aw mangai tlat. Chuan ta tang hian constant hi k ni ta sela. Constant hi k ni ta sela. P chu const k by v square khani don ta ni. dv chan chu volume agani degree don tlat ta hian. Chuan k chu constant ni vain kan pot chhuak theya. V square kha v power minus 2 dv mo. Chuan k ni ta a chu hai from v1 to v2 ni ta sela. Chuan minus 1 by v ni don ta ni. V1 to V2 mo. Chuan W is equal to minus helai minus kan pot chhuak anga minus K 1 by V2 minus 1 by V1 ani ta ni. Chuan minus and multiply le ta ila K ni ta a 1 by V1 minus 1 by V2 ani ta ni. Chuan work done tur chu K by V1 minus K by V2 ani ta ni. Chuan K chu constant kan ti do khamo tira PV square khan K lukta a PV square khan K lukta chu ti ni chuan in K hianin P1 V1 square port luk theya P2 V2 square port luk the ta ni K ani ta ai nang ve ve don ta ni. Chuan V1 omna hianin helai V1 omna chung K a hianin P1 V1 square his kan da ta nga chan chu K khan atluk ve ve sia. P1 V1 square by V1 minus khetai K a ve thung chuan V2 zok hi o kan omna kan da lenga P achan chu K khana tluk ve ve thawa V2 square by V2 ani ta ni. P1 V1 minus P2 V2 hai ta ni. Chuan ideal gas equation na khan en chuan in PV chu nRT khan ya. Chuan in P1 V1 chuan nR T1 khan don ta ni. nR T1 minus nR T2 kha. Chuan nR common ta nR T1 minus T2 khan don ta ni. Chuan T1 minus T2 chu delta T khan ta nR delta T mo. Chuan hei work done kan nei ta ni. Chuan in work done by the gas to change in its internal energy mo. W by delta U kha ni ta chu nR delta T by delta U kha nge kha delta U kha n into 5 by 2R delta T kha ni ta ni. n into 5 by 2 r delta t mo n cancel nga delta t r mo 2 by 5 to 2 0.4 khani 0.4 answer to option B khani. Number 13 answer to option B 0.4 khani. Chuan next number 14. Question number 14 khan. 20 gram of ice at minus 20 degrees Celsius is dropped in a closed container having 40 gram of water at 50 degrees Celsius. The temperature of the mixture will be at itani. Le voot langa omtani tihian. Voot langa omta a atira a temperature to minus 20 degrees Celsius ani chuan amma sahi 20 gram anitani. Hi ice anita a chuan heta tuya omta ne tihian tuya omta a tihianin te tui hi atira chuan a temperature chu t water taila 50 degrees Celsius anita ne chuan a mass kha capital M mang taila 40 gram anita ne chuan he vut langa hi tuya hian kan zum da ta ne chuan a vot jok kha vut lang hi nia tui hi lung jok ka chuan heat transfer om tur chu heat transfer chu water atang khan ice a heat in transfer doni chan chu temperature an hiam joka chuan ta hian kan man tur chu ice hian heat again charanga water hian heat a loss char thung don ta ni common temperature anin anom ma chu chuan chumi tu chuan principle of calorimetry kha kan man angai ta ni principle of calorimetry chu heat loss by water ina heat loss zong ka ice khan alo la vek don ni heat gain by ice ani ta ni le je chu tian kanan da dun ta a ice kha om ta ni chuan vut lang hi vut lang hi tui tur chuan 0 degree Celsius thlen photangai ta ni solid ala ni reng don ta 20 tanga minus 20 atanga minus 20 degree Celsius atanga 0 degree Celsius thlen khanin solid ala ni don ni chu wang chuan ta chuanin heat loss by water chu mass of water into specific heat of water into delta t khani a water mo chuan ice hian in heat chong hin again don ni ama sabera chuan minus 20 degree Celsius to 0 a thlen nan hian heat again photanga ta chuan solid ala ni reng chuan ta chuan in ms delta tiang thoi kan mang m into s ice more specific heat of ice into delta t of ice anita a chuan 0 a thlen to chuan in atui tan don ta ni minus 20 to 0 action solid ala ni chara ta chuan a temperature khan 0 a thlen huna khanin atui tan do ni tatang chuan in melting kha in tan to melting kha in tan to do ni chuan melting a in tan to chuan in m into l laten heat kha kan mang tong chuan 40 gram ta le tro 40 gram anita a specific heat of water kha 4.2 joule per gram per degree Celsius ang deuh khan ta a chuan gram le gram in cancel anga chuan delta t hi atira a temperature mo 50 minus t in ta ni chuan t hi chu final common temperature tur khan helai t hi chu mo final common temperature tur khan ta a chuan equal to ani ta a mass of ice kha 20 gram ani ta a 20 gram chuan specific heat of ice mo vut lang ani la specific heat kha 2.1 vel ani ta ni 2.1 joule per gram per degree Celsius ang vel khan ta chuan plus 20 gram into latent heat of ice kha 334 vel ani ta ni 334 joule per gram vel ani ta ni mo chuan gram cancel ta ngor o ta hian thil mai ka nei sorry thil ti mai ka nei lok min lo hra thiam lok hela hianin into change in temperature kalo tile reng hene ta chuanin helaya chuanin helai delta t hi minus 20 to 0 ni wangin mo a change a magnitude of change to 20 ni don ta ni 20 degree celsius mo 20 degree celsius kan ta a chuan kan celsius in cancel anga gram le gram in cancel ang chuan latent heat of ice kha plus ml mo 20 gram into 334 joule per gram gram le gram in cancel anga tikhan ani ta ne chuan helai t hi kan zon tur khan ta ni helai t hi mo tuna ka ko na lai hi t chuan 40 into 4.2 per degree celsius mo hi te chen cancel thia 4.2 into 50 minus t equal to 20 into 2.1 into 20 plus 20 into 334 khanitani chuan 20 hi la right hand side lampang hen la 20 hi a common tani 40 into 4.2 into 50 minus t equal to 20 ten jek tamai la 20 into 2.1 plus 334 khanitani 20 in 2 chuan 8.4 into 50 minus t equal to hi ten ai no thaya 42 ani tani 42 plus 334 chu ang zat nge 6 ani ta a 7 376 ani ta ne 50 minus t chu hianin 376 by 8.4 anita a 3760 by 84 anita ni chuanin an chu don ta ila 3760 by 84 chu 3760 by 84 to 44 vel anitani ro hela hianin engeti so kanin me ta hianin mc delta d20 option khai nge kha 10 50 ve 40 kan chui lok o ms delta t m 40 gram water specific heat 4.2 dika 50 minus t 20 to 2.1 to 334 ml dikhi chuan 50 minus t chu 3760 by 84 chu 45 vel nei ta ni 45 mo chuan t chu 50 minus 45 chu 5 degree celsius answer chu option d khani number 14 answer chu option 10 as the temperature of a body increases, the wavelength corresponding to emitted radiation having maximum intensity at the time. Đây chu Wien's displacement law khani Wien's displacement law chu mem je chu black body radiation a re chuan in temperature san chuan in intensity ni ta a hi wavelength ni ta ni temperature T1 ni ta sela chuan T2 a chuan hi ni don ta ni hi T2 chuan T3 a chuan hi ni lenga ti hian hi T3 a chuan entala hi maximum intensity omna wavelength hi atlem tel ani chuan lambda max T is equal to constant B B hi Wien's constant ni ta ni chuan je chu temperature san chuan lambda max hi wavelength which has maximum intensity ni wavelength which has maximum intensity so ni chuan atlem tel ani answer chu option temperature san chuan lambda max value hi atlem tel temperature san chuan lambda max hi niam tel ang hai ang graph atang hin taula temperature T1 a chuan intensity wavelength chu hela hi ni maximum intensity wavelength chu la hi ni ta T2 a khan hela hi chuan T3 a khan hela hi ni vathum hey a intensity maximum intensity omna wavelength hi atlem tel ani kha Wien's displacement law ina sai chuan ta answer chu option C decreases ani chuan number 15 khalo en le lok ta ila han tik to hrimanga number 15 a body cools from 70 degrees Celsius to 50 degrees Celsius in 10 minutes ani tani tatang hian equation an siam taila 70 minus 50 by 10 rate of cooling more equal to K times 70 plus 50 by 2 minus surrounding temperature 20 chuan 20 by 10 is equal to K ni ta a 70 plus 50 to 120 by 2 minus 20 to 60 minus 20 to 40 K kha ni ta ni chuan tatang chuan in 2 is equal to 40 K ni ta a K to 2 by 40 1 by 20 kha ni ta ni chuan dot lekha 50 to 10 50 to minutes som nu kha ni ta ni mo 50 degrees Celsius atanga minutes som ka lekha nin enge a final temperature tur ani ta ni chuan 50 minus T prime by 10 equal to K times 50 plus T prime by 2 minus 20 kha ni ta ni chuan 50 minus T prime by 10 equal to K ni ta a chuan hi split taila 25 more 50 by 2 plus T prime by 2 tian all sum zokang ma ti LCM la khelo khanen 50 minus T prime by 10 equal to K ni ta 25 minus 22 5 ani ta ni 5 plus T prime by 2 khani ta a chuan K kha substitute ta ila 1 by 20 5 plus T prime by 2 khani ta ni T prime chuan 50 minus T prime by 10 equal to 1 by 20 5 plus T prime by 2 khani ta a chuan 50 minus T prime chu 10 by 20 5 plus T prime by 2 khani ta ni chuan 50 plus T prime 50 minus T prime chu 2 can multiply 1 by 2 can multiply 5 by 2 plus T prime by 4 ani ta ni chuan 50 minus 5 by 2 equal to T prime by 4 plus T prime ani ta chu 5 T prime by 4 ani ta ni chuan 100 minus 5 by 2 equals 5 T prime by 4 ani ta a 2 draw 195 ani ta a 5 by 2 T prime chuan t prime chu 95 into 2 by 5 ani ta ni 5 in 5 1 is 5 9 45 ani ta 38 degrees Celsius answer chu option B kha ni khan number 6 15 answer chu option B kan chok chuak ta ka ti sol kha ka hramai theilo atla mi hi lo ring mai ru answer chu option B 38 degrees Celsius kha ni